For joining us today for this mentoring session on AI. We have about 103 people who are going to be participating, so we're very excited for you to be here. I think we'll give you a couple of minutes for some stragglers to come in before we actually officially get started. We have three pretty well-known speakers here, so we appreciate them agreeing to enlighten us about what they've been doing with AI. I think what you're going to find out is the topics are going to be pretty broad and wide. And so the general structure we'll follow here will be that we will let each person present, and then we'll save questions until the end. So I guess I should probably introduce myself. My name is George Davis, and I am at Virginia Tech, professor in ag and applied economics here, and am on the mentoring committee. And so we were putting our heads together, I guess, last year about what we wanted to do for a webinar, and obviously with the advent of AI and the revolutionary aspects of it and how it's changing all our lives, we decided that may be a good topic. So we did a little research, found Aleks and Carola and Madhu had been doing some work in this area, so I asked them to come talk to us about what they're doing. Before we formally get started, I really want to thank Allison Ware and Austin Sparabell for helping us get all this set up, and certainly our chair, Jacqueline Kropp, who's at University of Florida. So I think Austin is going to turn over to me co-hosting abilities. And I think he's already done that. Is that right, Austin?
That's right, you're the host.
So I'm it. Tag, I'm it. So so anyway, I thought what we're going to do is get started here. And let me share my screen because I've got a couple of slides here I'd like to show you in terms of the kind of what we're going to be doing today. So can everybody see? I don't know which screen you're seeing. Aleks, which screen are you seeing? Are you just seeing the front first?
We're seeing the first two screens. So if you go to display settings up there.
Yeah. Oops. Up at the
yeah, right up there at the top, display settings.
Where is it? Oh yeah.
And then either of those.
There you go. All right, good. So you're just seeing the cover slide, right?
That's right. Yep.
All right. So the title of this kind of webinar series is called Sharing Our Struggles and Successes. So the idea of this, again, being mentoring committee, is for us to share information regarding struggles and successes within the profession. But today we're going to be talking about AI in academia and beyond. And as I indicated, my name is George Davis from Virginia Tech. Our panelists today are Aleks Schaefer at Oklahoma State, Carola Grebitus, and Madhu Khanna from University of Illinois. So our first person to speak to us is Aleks, or just Aleks, has told me, an associate professor at Oklahoma State. He's a senior fellow of the National Center of Food and Ag Policy in Washington, D.C. He holds a Juris Doctor from University of Kansas and a PhD in Agriculture and Resource Economics from University of California at Davis. His research is at the intersection of law and economics in food and the agricultural sector, and he serves as the editor of Agriculture and Resource Economics Review, and is an associate editor for both the American Journal of Ag Econ and Agricultural Economics. So with that, Aleks, I'm going to turn it over to you. Stop my sharing and give it to you.
Cool. All right. Are y'all seeing my screen?
Yep.
Okay. Yeah. So I guess since this is sharing our struggles and successes, or whatever the title was. I'm not going to wax poetic about AI in a big picture level. I'm just going to be honest with you about how I have been using ChatGPT. All right, so, oops, let's see. Yeah, George said to share a little bit about ourselves, and so I'm from a tiny little town in Panhandle of Texas, and then Southwest Kansas. I went to a little Bible college in Wichita, Kansas, where they didn't have this thing called economics. So I'd never heard of economics, didn't know that was a thing. I majored in Spanish because that's what all the pretty girls were doing. And then I went on to law school thinking, you know, I'm going to save the world, focusing on international trade law. And pretty much as soon as I got to law school, I learned law school is really good at teaching you how to advocate for this side of something or this side of something. But it is really bad about the should, like the objective should. If we want to make the world a better place, what should we do? And so at law school, kind of I finally learned what economics was. And as I was doing my law classes, I was frantically taking all of these calculus classes to try to gear up because apparently my Spanish degree wasn't good enough for admission to a PhD program. So taking all these calculus classes, graduated law school, took the bar exam, and then the very next week I started my PhD program. And man, I'm glad I did, right? I've gotten to go all over. So my first job was at the World Bank, and then I was a professor in London for a while, Michigan State for a while, and then finally kind of back home to my part of the world, Oklahoma State. George asked us to talk about some mentors that had been important to us. And I think, if I'm completely honest about my kind of career trajectory and career development, it wasn't like a top-down mentor. It was my cohort at UC Davis. These were people who had studied economics, ag econ before, knew what they were talking about, and helped me learn how to think, how to code. And I've gone on to publish with them, I'd say, for the majority of my research. So I'm really thankful for them. All right, so at the same time, I'm really thankful for them. I used to be more thankful, but George sent out this announcement saying, hey, we got this mentorship workshop. It's Aleks, Schaefer, Carola, Grebitus, and Madhu, Khanna. And just about everyone that I've ever met texted me and said, why the heck are you on this panel? Which made me feel great about myself. And so I would like to now answer that definitively for all those who have asked. And the correct answer to that is the next slide here. I don't know. I don't know why they asked me to be on this panel, but I am very honored to be participating. If I am completely honest, I think it's because a couple years ago, we wrote an early paper, kind of ChatGPT and some of these programs had just come out, and we had sort of this moral panic of, oh no, if we have ChatGPT, students aren't going to learn anymore, and they're going to be using this stuff to make up essays, and they're not going to develop writing skills or thinking skills, and the world's going to fall apart. So we decided to do a little experiment to test that, where we took a repository of historical kind of essay-based answers from a real class, and then had ChatGPT 3.5, so an earlier version of that, answer those prompts, and then on a blind basis had some instructors grade those exams. And we did find that ChatGPT, even that early model, was good enough to receive an A, whereas the average kind of student-generated response was a B. So this was a long time ago. We know AI has gotten a lot better, but also my perspective of AI has really evolved. So I used to be really focused on those risks, and I think that those risks are really still real, but I think kind of in practice, my guess is that Carola and Madhu are going to disagree with me, but I think in practice, maybe those risks are not as big as I expected. I think students do want to learn how to do this stuff. They don't want to just skate by. They do want to develop these skills. And in that context, some of the AI tools that my kids are using, that kids in this college are using, are hugely beneficial for tailored, kind of person-to-person tailored learning. And they have been really, really productive in my own life and research. So that's the part I'm transitioning to, is the how have I used it in my own life and research. And I just want to be honest with you that I feel super vulnerable in doing that because at least in my office, it's still a little bit taboo to kind of admit that you're using ChatGPT or these AIs to do some of your work. Uh, yeah, it feels professionally risky, but I do want to be honest about how I'm using it because I truly believe it has made me a better researcher, a better writer, and a better teacher. So let's do that. So my first stop in this, Aleks, how have you been using ChatGPT for your work, research, extension, education? Well, I said, hey, ChatGPT, why don't you look through all of the threads that I have had with you, and can you summarize for me how I have used ChatGPT for these things? And it said, yeah. And it gave me some answers. So here is the output from ChatGPT. It says, you, Aleks, use ChatGPT kind of as this personalized chief of staff for managing your workload, and then also as a research assistant to refine, polish, structure, and strengthen the stuff that you're working on. I use it, and this is right, for rapid iteration. So if I don't like a version of something, I get it to generate something, and I say, but this isn't perfect. Can you change that? So then I get it to generate again and again until it really fits kind of what I'm working on, kind of what substance am I using it for, emails, helping me write tailored letters of recommendation, kind of memos, summaries, outlines. This is ways that ChatGPT really reduces the costs, the transaction costs of my job, to give me time to focus on the kind of the big picture thinking stuff and sort of swing for the fences, be brave in some of the research projects that I'm working on, the grant applications that I'm submitted, rather than worrying about making the safer bet because of all that time. That the reduction of that time lets me focus on some of these kind of lower probability big swings. I can use it to think through problems as a conceptual sparring partner, and I really do use it in all kinds of domains, really, of my whole life, right? So outreach, teaching, administration, creativity, and then just helping me manage Aleks. Okay, and just here's some bullet points to be a little bit more specific about some of that. It's I come up with an idea and it helps me think through, well, is this the dumbest thing you've ever heard, or does this have some legs? Is this something worth investigating? So sometimes I've got a conceptual framework kind of in my mind, but it's not clear. And so if I can think through this out loud or with my fingers with ChatGPT, it helps me really clarify what the mechanism that I'm investigating is. It helps me clean up writing that's not very precise. And then, sometimes I get siloed in terms of the specific identification strategy that I'm interested in. It can take away some of those blinders to say, hey, well, have you thought about this as a robustness check, or some other avenues? Teaching, it helps me design. So if I say I want to hit this topics, it helps me think through how can I weave these things together in a way that kids aren't going to be like, all right, how does this fit with this? How does this fit with this? If I've got a really complex idea, it helps me sort of put it in a way that a novice can understand. If I want to bring some of these topics to the real world or make it a little more tangible to the kids, it helps me generate games or policy scenarios that we can practice in class. If I have been using the same frickin' multiple choice essays for the last 10 years, it helps me kind of spice those up a little bit, so that the kids that took my class last year aren't just copying the exam answers from the previous year. Similar to the research thing or the teaching thing, it helps me when I'm doing extension and outreach phrase some of my research findings in a way that non-technical audiences both can understand but find valuable. And kind of from the array of stuff that I've got helps me develop just the specific talking points for interviews and panels, professional communication and strategy is kind of where I use it the most here. So it helps me write my emails so that I don't sound as blunt as I really am in the real world. Sometimes if I just talk like I talk, it can really hurt some PhD students' feelings. And so ChatGPT helps me seem a little bit nicer, which is really valuable for all involved. It helps with those letters of recommendation. I read somewhere a New York Times article or something that was like, no, the cost of this thing is the value of this thing. And I just disagree wholeheartedly. The value of this thing is the personalized nature of these letters of recommendation. And I can get through those things by just telling ChatGPT, these are the things that I know about the student. These are the things that I want to say. Can you put this in a way that's going to be valuable for whatever graduate program they're applying to or whatever job they're applying to? And it can help me fit all those things into a system that's workable. It gives me advice on career strategies. Should I be an associate editor of a 16th journal, or is that not a valuable career strategy? A sounding board on administrative politics, and then a lot of people joke about ChatGPT being like always this cheerleader of whatever you say on there. It says, "Oh, what an insightful question! You're the smartest person that had ever existed," and a lot of times that's annoying. But heck, sometimes it is just nice to hear that my question that I asked is the most insightful thing that I've heard that ChatGPT has heard today. So thanks, ChatGPT. Um, yeah, and then it helps me, like I said, take some of these bigger swings. So uh, I would never have put in. I'm working on a documentary right now that we got funded, where I'm getting to travel all over and do all this fun stuff, and I just never would have gotten the chance to do that because the probability of getting a successful grant application for something like that is so small. And the cost of doing that are so high that it just doesn't make kind of cost benefit sense. But when uh, artificial intelligence is able to lower some of those costs, you can take some of those bigger risks in the way of doing some of the stuff you want. It also helps me in my real life, like doing my fitness routines, marathon training. Hey, this part of my body is hurting. Am I terminally ill? That kind of stuff. I've had a midlife crisis, and so now I'm doing community theater, and it helps me kind of reconcile that in my mind. So it's been really helpful in my personal life as well. And then I guess I know I'm up against time, George, so I'm just almost done here. What I don't use AI for, and I don't use it in that sort of moral panic worry that oh my gosh, we're going to stop thinking. I use AI to avoid the stuff that's the monotonous non-thinking parts of my job so that I can spend more of that time on the thinking parts of my job in a way that I've found really enjoyable. I don't use ChatGPT for literature reviews just because it's awful at it. And I guess one of the moral panics that I'm still having in ChatGPT or Claude or whatever one of these we're talking about is vibe coding. Vibe coding is this concept that you'll tell ChatGPT, hey, generate some R code. I want to run this regression and I want to do this, this, this. And then ChatGPT will spit out like a wall of code to do that. And it'll generate and it'll run and it'll give you results. Because I'm ancient, I've been working on code for a long time, and so I can kind of understand, make sense of some of the code that it's writing. But a lot of my grad students are new to coding. They don't have this experience, and they're vibe coding, hey, will you do this for me? And they don't have a clue about what this code is doing or how to interpret the output that it's given you in a way that I think may, in 5 or 6 years, be really problematic for research and sort of their research development and the credibility of the research that we're doing. So that's a thing that I'm worried about. I think that's the last slide. And this is my name and my email address.
All right, Aleks. Well, thank you very much. That has actually, for me, generated several questions already, especially with respect to your hobbies. but we'll come back to that. And we got a couple of questions that have popped up in the chat, but again, we're saving those to the end. So thank you. If let's move on to Carola, who is our next presenter. Come on. So Carola Grebitus is the Dean's Council Distinguished Professor at Arizona State, at the W.P. Carey School of Business. Her research applies various methods ranging from experimental auctions to choice experiments to eye tracking and taste test. Her current research includes consumer preferences for imperfect foods and the effect of mindfulness on health food choices, willingness to pay for domestic and imported beef, and the influence of food labeling on purchase decisions. She has published in the AAEA, Business Strategy and the Environment, the European Journal of Marketing, and has been recognized for her efforts in teaching, research, and outreach with awards such as and Carola, you'll have to get the pronunciation on this one for me, the Huzing Award for Undergraduate Service to Students, the Centennial Professor Award, and the W.P. Carey Dean's Mid-Career Research Award. So, Carola, thank you, and I am turning it over to you.
Thank you, George. Can you see the presentation?
Yep, got it.
Okay. So when George prepped us what to do, one of the things he threw out there was like, why agribusiness? And that could be a book. So I'll make that short. I love food, and I've always loved food, at least looking at this picture. And I love baking and eating, and in my research, I love looking at food labels and everything related to food. And I still like the occasional baking the occasional cake. And but for the actual journey, because I like food so much, my first degree was actually in food science, which since this is the mentoring. Sometimes that still haunts me because my degree was not in agricultural economics, it was in food science. But it motivated me to look more into food economics. We had some classes on food marketing, home economics. And so between the bachelor and the master, I switched from food science to food and home economics, and then did my PhD in agricultural marketing. And I did all of that at University in Germany, and there's a picture of Jutta Rosen, whom you probably know. She's an AAEA fellow. Jutta was a professor at Kiel University while I did my PhD there, and she's now a professor at Munich University. We are still collaborating a lot, but what was important at that stage was that she suggested that I probably go to Iowa State and be a visiting scholar there with Helen Jensen. So Helen became my next mentor, or also one of the many people who have mentored me. And that's really how I got introduced to the American system, the American academic system. And I think it was already at that point where I was like, I kind of like it better here the way than it is in Germany. And so I tried to find a job, and I became a postdoc first at Iowa State and then at University of Alberta. And there's Ellen Goddard, who also joined the club of my mentors. And I really tried to get a tenure track position in the US, but I didn't have an American degree. So I had to go back. Germany. And I was assistant professor for 5 years at Bonn University. There's Monica Hartmann. She was my boss. She was a department head where I worked. And she also was very influential in my career from assistant professor stage on. And so it took another 5 years until I got a job at Arizona State University. And there's George. There's George. Because when I started at ASU in 2012, I was able to get into the AAEA mentoring program, and George was my mentor. And back then the program was 1 year, and George talked to me every month. And he's still talking to me a lot. But that was so helpful because I didn't grow up in the American system. I didn't really know how it works here, what to pay attention to. And then there are Jason Lusk and Rudy Naiga, who already started research with me while I was at Bonn. Jason was my mentor in the Sylvia Lane mentoring program. So this is just a brief snapshot of my mentors, and there are many more. But I think in this job, it's so important that you have mentors that you can trust and who can guide you, because it is a very long journey, or it can be a very long journey. And there are just a lot of things that may not be obvious to you, that you may not know. And I would be remiss not to mention Gerda Reif. She is actually my business coach. I met her when I was in Bonn. I was in a female mentoring program there. I met her around 2008, 2009. And she is a coach specifically for academia. And I still talk to her. Sometimes once a month, we just have these coachings. And I feel like there's always something. Like, for example, right now, I want to go on sabbatical next year, but I want it to be productive. So I have strategy meetings with her. And since this is the mentoring workshop, to me, that is so helpful. Like, she is not in my department. She's not even in the US, but she's specifically a coach for academia. She knows a lot about academia. And whenever I need some advice, I know I can get that from her. So wanted to give her a shout out. And with that, switching to AI, I started this research project in spring when Matt Rousseau, who's a longtime colleague, co-author, told me about this idea that he had. Like, could we just test LLMs, large language models, to see if we could use them kind of like participants, right? And so the first thing is, like, we're working on experiments. We do experimental economics. I don't want to put myself out of a job just by finding that I could just ask ChatGPT to give me a data set and then I don't have to do anything anymore. But what about all the benefits that we might get from kind of collaborating with LLMs to make our life easier? Probably do a pre-study. Maybe we could get bigger samples. So Matt had this idea. At that point, I actually had not really started using ChatGPT. So I also felt like that could be an incentive to really get me started, look more into that. So together with Jake Corrigan, we worked on this paper. And I just want to give you like an idea of like what we did, and then maybe you get your own research ideas from that. So when we started there, and I think still there has been no assessment on whether we could LLMs to help do some experimental auctions. I do a lot of discrete choice experiments, so that will be my next project. Maybe we can use LLMs to help with that, to assist with that, because these are methods that we use a lot in ag econ. And it's an important question because when we conduct studies, whether that's in the lab or online, that can be very expensive. It takes a lot of time. You have to pay the participants. So what if I was able to do a lab experiment with 100 people, but I don't just want to say something about what's going on in Mesa, Arizona. I want to say what's going on in the US, right? Maybe when I have my small sample, maybe I could use ChatGPT to get a broader data set. Maybe that's possible. So that's our study. How well can LLMs emulate human bidding behavior? And among the research questions, we have a paper there, we have more research questions, but here I just want to focus on, can LLMs generate human-like bids without any reference data? Like, could I say, like, okay, I have a new, I have this water bottle, right? Like, what would participants across the US pay for this water bottle? And we want to test that. And then we want to know what happens if we could provide some reference data, because if I can do my lab experiment, I would have some reference data. I could give that. to ChatGPT and say like, okay, this is happening in Arizona. How would that look for the US? And our experimental design is that we have a 3x3 design. So we test 3 LLMs, then we test 3 reference levels. We have no seed data, we have 10% seed data and 20% seed data. And the experiment that I want to show you, just as a brief overview, is an experiment that we did in the US where we have human data. The way we did that is that we uploaded our experiment instructions, just exactly the instructions that the participants in the lab got. Then we provided the participant demographics of our sample. Then we provided the reference bits, either none or 10% or 20%. And then we prompt for the new bits generated by the LLM. We export the data and we analyze it. So here's the auction I want to show you. This was a coffee auction. Our data set is actually data from 107 US participants. This was a non-hypothetical auction. So the participant who won actually had to pay money. We used 6 labeled coffee bags where we tested, for example, a fair trade, certified coffee, direct trade, USDA organic, or Rainforest Alliance. And then we gave the LLMs the participant information and the auction instructions and asked to complete the bids, either for all participants, 90% or 80%, depending on the reference data. We used ChatGPT, Google Gemini, and Claude just to see are there any differences depending on the LLM. And let me show you the results. If you want to play along, you can tell me in a minute if you think ChatGPT can give us accurate data. So here you see the bid in dollars per coffee bag. We have the conventional, the direct trade, fair trade, certified, and so on. And these are the original data. So now you want to put that in the chat. Do you think without any reference data, ChatGPT can generate average bids? And mind you, the data we got was really per participant that we input, but just let me know if you think that ChatGPT can actually come up with comparable bids. And Georgia did not pay attention at all to the time, so you have to stop me.
You got a couple of minutes left, so I'm going to guess. I'm going to speak for everybody. I don't see anybody put anything in the chat. I'm going to guess it's going to probably surprise me and do better than I think it would be able to.
Okay, so
here's somebody.
Okay, so what we heard, it would be a yes. Okay, so let me show you. Don't be disappointed. So it could not do that. Okay, this is significantly different. So even if you just do that in your mind, if I give it 10% reference data, do you think it'll be better?
Yes.
So much better. So much better, right? So I don't have the data here. You can see it in the paper, but at one point we did not find much statistical difference anymore. Will that even improve if we give more data? So we tried 20% of the reference data. Not really a big difference there. So that was the first one we tested. That was ChatGPT. So here's Gemini, and Gemini was pretty similar. It can do it without any reference data, but once we gave the reference data, it got pretty accurate, right? 248 versus 244, for example. What do we have? 319 versus 313. Not huge differences. And the same we found for Claude, except Claude was way off. You know, if you want a good guess, do not go to Claude. Claude did not guess so well, but once it had like our reference data, it became much more accurate. And that's what we found overall, dramatic overbidding when not giving reference data. But once we gave some reference data, the LLM bids became quite similar. And whether that was 10 or 20% didn't seem to matter much. We did more tests. We also had an experiment with apples. The results were pretty similar. So overall, our conclusion from this was, if we give a small amount of reference data and demographic characteristics, then the LLMs are actually capable of generating bids that approximate human bids. We don't want to put ourselves out of work. So what we are thinking is more like, maybe we can use this for pre-tests or pilot studies for our own research. For example, when I generate designs for discrete choice experiments, I usually need a lot of pre-testing, and I may not always have the budget to do that. So obviously this requires much more testing than what we did here with this exercise. But if we could be sure that this actually works, it could help us a lot with that. It could help for grant proposals where you just want to say, this idea is worth funding to have an actual human sample. You know, it's probably a question worth investing in. We could potentially use it to increase sample size, to go from a regional to a national study. Could we even go from a national to an international study? So overall, I found this really interesting. It helped me to get used to the technology and to think, like, how can I use this in my own research? How can I make my own research better? And I feel like with every research project I do, once it's done, we send it out to the reviewers. We got so many comments, and I came to find that there's so much more that I don't know about AI and LLMs. So now I'm collaborating with a computer scientist just to know more and learn more and have more certainty about what we're doing. But for me, to have a starting point to get going with this, it was incredibly helpful. And that concludes my presentation here. If you're interested in the paper, it's on SSRN. And yeah, I'll be curious to see what you all will come up with when it comes to AI.
All right. Well, thank you, Carola. That's quite fascinating, I tell you. And I look forward to questions about that, because I'm sure there are several. So we're going to move on to our final speaker, who is Madhu Khan, which, and again, I have to, I don't know which one y'all are seeing. Are y'all seeing the full screen? There you go. So Madhu is the ACES Distinguished Professor of Environmental Economics in the Department of Ag and Consumer Economics, and the Alvin H. Baum Family Chair and Director of Institute of Sustainability, Energy, and Environment at University of Illinois at Urbana-Campaign. Her research is at the intersection of agricultural, energy, and environmental economics. She has served on the US EPA Science Advisory Board for 10 years and is a chair, member of panels and advisory committees for NEFA, USPA, NSF, and the National Academy of Science. She's also served on the board of directors of the Ag and Applied Economics Association and Association of Environmental Resource Economics. She is, as many of you know, she's a fellow of the association, and she's also a past president. She's also a fellow of the European Association as well, and she's a member of the board of directors of International Association of Agricultural Economics and the International Consortium of Applied Bioeconomy Research. So, Madhu, thank you for joining us, and I will turn it over to you.
Thanks, George, and thanks for this opportunity to be here, and thank you all for listening in. Let me just share my screen here. So my interactions with AI are different. I'm interested in studying why farmers would want to use AI technologies. And I'm going to describe to you a little bit of how I got into this area of research. But before that, just a little bit of my own personal journey. It started about literally about 36 years ago. So when I was looking around for a PhD program and was in Berkeley, thinking I'd applied to the Department of Economics, met a professor there who directed me towards ag and resource economics that I did not know about. That was, prior to the internet. So at the risk of aging myself, I mean, 1989, 1990 was before the internet was there. And so there was no easy way to search around, and there was a lot of word of mouth and learning from people. And so that's where I, discovered that that's the kind of stuff that I wanted to study. And as an international student, it was a place easier to get funding and so on. So it was a bit of a serendipitous entry into ag econ, but and then just on a personal note, something that is not on my resume is that just around the time that I was applying and about to get admission and all of that, I also discovered that I was expecting our first daughter. So it was, the struggles and the successes kind of were going hand in hand from the very first, from the very beginning. And wanting to do both, have a family and do a PhD, I proceeded. My daughter was born about 10 days before I started the PhD program at Berkeley. So, they're both August, and there I was in about 10 days from the hospital onto the wooden chairs in the classrooms at Berkeley, learning about microeconomics. I was fortunate enough to get fellowships. And so I didn't have to do the research assistance, which was a great saving of time. And then it was only really in the summer that I was looking around for some research assistantship and encountered David Zolberman, who took me on, and it was through my work with him and that he became my mentor and really in some ways has been more than just a mentor. He became the kind of life coach that Carola was describing to you. I had to go back to India for family reasons and also do some field work and so on, and I had no clue after my second year, what exactly I was doing. And he would talk to me on the phone. And at that time, phone calls internationally were just, so expensive. Every minute was like $20 or something. But he would spend an hour talking with me about what I should, the research issues and so on. So, it's just been somebody who's kind of helped me through. And I think you need that kind of relationship with your mentor, which is sort of goes beyond, it becomes it's a lifelong relationship. And so it was really through my work with him that he was working a lot on irrigation. He does a lot of work on technology adoption. One of the things he'd been working on was irrigation technologies, and that's a research project that I was hired to work with him on. And so in working with him, that whole idea about how these technologies, there exist these technologies that increase efficiency with which we use our inputs in agriculture or broadly, and so what are the incentives to adopt those technologies? And not only can those technologies improve the efficiency of input use, but they can also increase productivity. And whatever is not used by the plant is left over and becomes environmentally, an environmental pollutant. And so you can really get these win-win benefits from certain technologies, irrigation being one of them, where, sprinkler and drip are much more efficient and can reduce runoff and so on. But in working with him, I kind of, we in our conversations, we realized that that's much more broader than just a single example. And in my dissertation, I looked at electricity generating technologies, which have very much similar features. And then got into this whole idea about nitrogen. When I came back, I finished my PhD, and I was here in the Midwest. I got hired at the University of Illinois. And one of the big issues in Illinois, in the Midwest, is nitrogen pollution. And so we realized that kind of nitrogen suffers from exactly the same problems as irrigation, is that there's over-application, runoff, and low efficiency. And so this sort of my first paper was really about how we can develop incentives to have more of this precision farming, where you've applied the right input at the right time, the right level, and that increases efficiency. And so my initial work really started with trying to understand how we can make production agriculture more efficient. And you have these potential for these win-win solutions, but yet nobody adopts them, or the low rates of adoption. And so a lot of my early research really focused on what are the incentives, why, what are the barriers, and there's lots of behavioral reasons and economic reasons why adoption doesn't occur, and so on. But then precision farming in general, while it sort of initially started to take off in the Midwest in the 1995s or so, with the development and application of GPS technology and so on, it then kind of stalled. And one of the reasons it stalled was because even though we had all this big potential to gather huge amounts of data, and make all these maps, and we even had the technology to apply inputs at variable rates across the field, we really lacked the information to be able to analyze all that data that we were getting and do high-speed computational analysis with it, and then make predictions and recommendations that would really make a difference in terms of how crop management was being done. And that lack of that knowledge was, I think, a key factor why farmers were not seeing the benefits, and there wasn't enough incentive to adopt. And so, I had this research. It was it had been done. I moved on to do some other related research, and then had an opportunity to organize a stakeholder event. And because of my interest in this whole nitrogen, runoff challenge and the hypoxia problem in the Gulf, because of that, I organized a stakeholder event on trying to understand people's perspectives on why don't we do better and adopt these technologies and so on. And then I was, through various events, I led this perspective paper on that got published in Nature Sustainability on how can we harness emerging technologies and to reduce the Gulf hypoxia. And so, along the way around in 2020, there was a group of people. So there was a big call by NSF and NIFA to submit proposals to, these $20 million proposals on how AI could be applied in agriculture. And a group of people from my university, essentially computer scientists, had a networking event to sort of seed some ideas about putting this proposal together. And which is something I don't always, I don't do enough of, is to go to these types of networking events, but I did go to that one because I was sort of excited with the possibilities. And then the other thing I don't do is very good at doing is sort of selling myself. But this one exception, I did carry this paper with me, which is really just a 2,000 word, paper, and gave it to the people, the guy who was kind of the lead. And he got really excited about it. And so, long story short, I was asked to be one of the leads on the technology adoption public policy thrust of that proposal, and that proposal got funded. And so I was now in this project that was I was the only economist, and there were computer scientists and agriculture engineers essentially, and soil scientists and others. And the good thing about that was that nobody quite understood where the economics would apply and all of that, and neither did I. I mean, I was sort of just beginning to even learn about what the technologies were. But the good thing was that there was a lot of leeway for me to figure out and to develop my own kind of research ideas and to see how economics could contribute to that. And so there was no predefined role for me, which sometimes we worry about when we're asked to participate in these interdisciplinary projects, is that, well, are we just there to put the dollar figures against things that the other sciences are doing? And here it was, I could design and define my own research. So essentially the key things with AI in the context of agriculture is that it really addresses two major challenges that agriculture faces. And the first is that there's this incredible spatial heterogeneity in the field. Even at a subfield level, there's so much heterogeneity that if we don't manage that, we're really giving up on productivity gains and so on. And the second big problem is labor shortages and the need that we cannot do things that are sustainable, but that require that time and effort and labor. It's too costly, and so they're not often done, and we apply inputs uniformly, and we do spraying of pesticides and herbicides, and in the process they are contaminating the environment, but also not benefiting the crops. So AI helps to overcome both of those. It can really provide the understanding of how to respond to spatial variability and in a much better way, reduce uncertainty of crop management decisions. It also provides these robotics and autonomy that can save labor time and be more site-specific and precise and so on. And so those are the aspects that appealed to me, we sort of started to work on that. But I was really interested in sort of seeing what is it about. I mean, is AI just another technology? We've looked, we have a large literature on technology adoption, or is there something that's going to be fundamentally different about these AI technologies? And what that means, really importantly, for economic modeling and for analyzing adoption decisions. And so do we, as economists, need to develop new models for how we understand technology adoption? And there are several things that are going to be actually very different. Some of these are just emerging and not quite there, but we can see the trajectory. And here are sort of the top three things, which is that these AI-enabled technologies have their own objective function. They are developed with an objective function, and that may or may not be the same as a farmer's objective function, and you have to know that in order to look at how the technology will perform. The second is that in the future, and already beginning, AI technologies will have a learning capability. They will get better with training and with customization, and so it's not the static technology that you adopt knowing how it's going to perform. It will keep improving, and so how do you take that into account? And then the third thing is there's a black box nature. You get a recommendation from it. You really don't know what all went into it as a user, and so you have to either trust it or not, and that poses a whole different question that's different from a typical technology where you know what the technology is going to give you. So there's lots of new barriers to adoption, lots of new issues that we will need to study. And so that led to this paper that we published last year in Annual Review, looking at this issue of like, how does it need to change the way that economists study technology adoption, and what's going to drive the incentives for farmers that, was really interesting to work on. Just some examples. I mean, this is one of the like a weeding robot. This is an early prototype, and it can go in mechanically underneath the canopy of corn, soybean plants and pull out weeds without using herbicides and deal with the problem of herbicide resistance, which is something that is a major problem that is growing. So trying to understand, what the incentives for farmers would be of adopting this. And so that led to this thing that it's not just, again, like, should you adopt a robot or not? And as simple as that. There's a whole series of questions that come up because you have now many of these small robots. Farmers will need to adopt a swarm of robots and manage those. There's questions of how frequently to send them, how many to have. And in order to do that, we then ended up having to understand how weeds grow, how resistance grows, and what the weed ecology is. And then issues about whether they're going to own or rent. So it really opened the doors to a whole set of new questions that, we had not thought of before, that are very specific to the types of technologies. And as fortunate enough to be able to find, although starting off as the only economist in this group, I got a PhD student interested in it, and then a colleague of mine, Shadi Atala, who then helped to provide a little bit of critical mass to move this research forward. The other big example that we've been studying on is cover cropping is a big issue, the lack of cover cropping by farmers. And so this was, an automatic, it's a robot that can basically, you can put the seeds in it, and it can go into and plant the cover crop while the corn and soybean is still standing. So you don't have to wait till after harvest when the field is bare to do the planting. You can do this ahead of time. And so you can see from these pictures on the right, if you do it in like July or August and you plant the cover crop in warm season, it's much better established than if you wait till October, November to do this. And similarly, you know, there are drones and so a lot of these technologies are being developed here, and it really working with these, you know, the scientists who were developing this helped to understand what the issues were, the benefits and the costs and so on. And that could then, you know, we could look at that and develop some experiments, doing choice experiments with farmers and some economic modeling to understand incentives to adopt these new technologies. So in general, I mean, you know, for people who are sort of thinking about the future of what's going to come, you know, down the pike for agriculture, this is, you know, just like AI is becoming pervasive everywhere, it's going to be important in agriculture. And we're really at the very beginning on the left-hand side of that graph in terms of, you know, from precision farming to being able to use robotics and remote sensing to, you know, making, using, and even using these kind of LLMs to guide farmers. So they're crop wizards that are being developed that can help farmers, like a chat GPT for farmers that can help them get information quickly. But then it's going to go into supply chain traceability, which will allow much better, you know, labeling, because you can actually trace exactly how the product was, how the crop was produced from the beginning and to the consumer, much more easily. Digital twins, which can allow people to map, you know, the actual physical field with a virtual field on the computer, and you can actually make interventions on the computer and then try them out on the field and so on. So there's just incredible amount of potential to be able to use these, and lots of questions about, you know, is this going to improve sustainability of agriculture from an environmental perspective? And what does that mean for policy? There's, of course, a number of risks associated with this, you know, risks of cyber attacks and accidents and risk to human safety. And of course, underlying all of this data revolution, AI revolution, is the fact that we need data centers that are themselves going to be a big risk to our, you know, increased greenhouse gas emissions and so on. So just to conclude, you know, from just, you know, I guess from a mentoring perspective, I think the what led me to be able to kind of you know, make an inroad in this and get involved in this research was sort of an interest in interdisciplinary research and an openness to do that. And, you know, as economists, I feel like while we can really bring economic frameworks, but unless we have an understanding of the technology that we want to study and how it's really, you know, going to function and so on, and it's really hard to kind of apply economics in the abstract. And so what's exciting for me is to be to have a front seat at the table where you know, these discussions are taking place, so I can actually understand what you know, what the reality is, and then see how I can develop economic models around that. And you know, the other interesting thing is that you really you know, can see how economics can contribute to the discussion that engineers would not think of by themselves. I mean, engineers are very good at doing economic analysis, but they miss a lot of the behavior side of things. And what our research, you know, with these papers here shows that you can get things completely wrong if you ignore the way human behavior is going to interact with the technology. So so there's real value that we can bring as economists, and so I'd like to encourage, you know, those of you who are you know, thinking about areas to work on, to really see how you can, you know, participate in some of these interdisciplinary discussions and participate in that. This is also different from what a lot of people do. So it's not everybody is comfortable. You know, a lot of our economic research is focused upon on using historical data, time series and panel data, and trying to understand, why things happened the way they did. But really, when we're looking at things that are coming up, that are new technologies that are in the process of being developed, that are not even out there yet, we have to be thinking about how we model ex-ante choices. It's very forward-looking research, which is very risky and often makes people very uncomfortable. But it's also exciting research, and I think that economists can contribute a lot to that, because if we don't do it, somebody else is going to do it, and they'll probably get it wrong. And what's the point of looking at things 30 years later and saying it should have been done differently? Instead of being now and saying this is how we should be having policy. These are the things we need to watch out for, because they're going to be the ones that are going to, discourage adoption. So, and it opens the doors to new contributions we can make in our own field. So it's not just, contributions to other disciplines, but these really require new things that we hadn't encountered with existing choices that are available. And so there's really opportunity to do something really novel that can even inform our own discipline. And so some of the things we're working on now is how it's not just individual decision making, but there's farmer to farmer learning, especially with new technologies, pure effects, and then farmer robot interactions, and how those are going to work in the future, and using new tools like agent-based modeling to go beyond what we can do with within the constraints of economic models. So I'll stop with that. Thanks.
All right. Well, thank you very much, Madhu. I was especially interested in your weeding robot, having grown up on a farm where I weeded cotton by hand. So my dad had a weeding child. So anyway, we are right at the end of the hour. I think we have a few questions here in the chat. So let me, and I think this one came about, Aleks, if you're still here, one of the panelists, could you share how they chose between, well, before I answer that, I think, let me back up and try to tie all this together. I think the common theme you see throughout all of this is shifts in production functions. Aleks talked about how it shifted his production function in terms of his day-to-day work. Carola talked about how it could shift a production function in terms of actually research, in terms of getting pilot data, and obviously Madhu, it shift production functions for farmers. And there's just so many different aspects of this that come into play. So it's going to affect, basically everything. So let me ask this question. Could the panelists share, and I think Aleks, maybe you can speak this one, how they choose between AI, ChatGPT, Google, et cetera, the different platforms? Can you speak to that?
Only poorly, in that I used ChatGPT because it was the first big one. And so I started playing around with that one and got a subscription to it. And so that's the one I use. I've played around with the other ones on a free basis, and they give just about identical answers when you give them similar prompts. So to me, it hasn't been much difference.
So, and I think Carola gave a little bit of evidence that not in her context, there was some difference, right, Carola?
Yes, we found that at least without the seed data that we provided, Claude was a lot less good. Well, the results were very poor. And we also found that because we gave all our instructions and we had a protocol of like how we did everything step by step, but how we would provide the data, how we would get the data back. And that really worked the best with ChatGPT, like especially with Claude, like it would stop in the middle, you would have to start over or things like that. It just wasn't as smooth. So here at ASU, I was also able to get the ChatGPT version that ASU uses. I think it's pretty much the same, but it just says ASU. And so that is what I have then continued using, because it just seemed that it was a little bit better than the other two.
Yeah. So I think probably it's safe to say that it depends on the application and the question. All right. That's somewhat of a non-answer. Let's move on to another question here, which is this is actually with respect to the publication process. I'm curious about the way to approach the requirement that some journals have to acknowledge the use of AI, especially given that even MS Word and Explorers have AI assistants now. So I don't know what you all's experience has been with that. I think most journals now have a guidelines or procedures for about AI. Can anyone speak to that? I know, Alex, you're an editor, as am I. So, Alex, maybe you can speak. How are you all handling that?
Okay, so there are a few different answers to that. One is, as an editor, I think I've only seen one paper that I've been an editor for that has declared a use, but I use it a lot, and I'm pretty good at recognizing what's an AI generated thing, and I see it on approximately 90% of the papers that come by, right? Just the way that the sentences are structured, you kind of start recognizing the patterns, some of the words that they use. And gosh, I've been seeing those words show up a lot more frequently in 2024, 2025 than before. In terms of the how I have registered it, some of the reviews that or the AI declaration requirements usually say if you've used it for a substantive part of the paper, you need to declare it. And I guess I don't see kind of rephrasing and that type of thing as a substantive use. It's more
Yeah.
of a grammatical
Yeah.
use, and so I tend to not declare it either.
Yeah. 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 I think as I think Madhu may have mentioned, and that, as it gets more and more sophisticated, I suspect it's going to get harder and harder, right, to tell the structure, the repetition of the words, et cetera. So here's one that I'm sure we can close up and answer very quickly. What would be considered an unethical use of AI? Anybody want to tackle that one? I'll tell you what I heard. I heard someone who said that they were using it to write papers, and the way they were using it was they would basically do a reverse process. A lot of times you'll see papers and you get Copilot or something to create a PowerPoint, right, from the paper. They were doing it in reverse. That is, they were basically creating a PowerPoint with bullets and then saying write a paper. Now, this was in a different discipline, right? I think it would be very, very hard to do that in economics. But Carola, I'm gonna push you on this, right? Because obviously, you can ask it for willingness to pay. It seems like the next logical state would be, okay, write it up for me.
Yeah, I think kind of like where we are trying to test, could you use it? Unethical to me would be immediately if you just use it to generate data and then you pretend that was a human subject. That's human data, and not declare that, then that is obviously fraud, and that would be unethical. I think if you declared it, if you said, I'm testing this question with a sample of 1,000, but I use ChatGPT to get me the data, which is kind of why we are writing the paper, right? And when we look at the results that we got without any reference data, we see that that's not reflecting what you would get with an actual experiment. So there would be no value in that data.
Yeah, Madhu, I given your stature in the profession, I would be interested in your perspective on that, in terms of, being on the boards, and what are you hearing? Are y'all having conversations about that?
Well, I'm actually not on the board now, and I don't think, I don't think AI is, I'm on other boards, but I don't think AI is kind of, or issues with AI have kind of made it to those boardroom discussions. But yeah, I mean, I think, there is potential for unethical use if you're, um, get using AI to write a paper or do a literature review and claiming it's your own work. But I guess I'm sort of curious with to know from Carola and Aleks, who use AI much more for research. And my experience has been that even if you use AI to do some background research, there's still so much you have to do yourself. It's never enough, and it's because all it can do is to spit out what's already out there, and it's really most of the stuff that we're doing is going a little bit beyond what's out there in terms of drawing insights and things like that. So whether you can do it, but I don't know how publishable those pieces would be. But certainly I think the question is really for when students do it, how do you distinguish between what was an AI generated versus generated by a human? And I think there are some software and all now to be able to test that, so there may be ways to prevent it.
Yeah. Well, I want to be sensitive to everybody's time. We're about 15 minutes over. So I want to thank all of our panelists for very insightful presentations across a wide range, from personal use to research to modest implications for agricultural productivity. I think it's very useful. I'm sure this will be the last conversation we'll ever have on AI going forward. So
We
I'm glad
solved it.
we were able. I'm glad we were able to settle all this. If anybody has any questions or comments, in all seriousness, please feel free to email me, George Davis at VT, and I will get you hooked up with Aleks or Carola or Madhu to answer the questions. So anyway. Thank you all again very much, and I hope you will have a wonderful weekend.